Okay, so we were here, and to enter this in an interval notation, you have, so I had this one. I had x is greater than or equal to the square root of 31 over 30, which is right here. It's all the numbers that are bigger than this number, but you can include this. Now, the other branch, you have to do the U symbol for union, because this is the other branch, which is from negative infinity all the way up, so negative I and f is what they want you to enter, all the way up to this value, negative square root 31 over 30, and you can include that value. So you're entering in this, then the union symbol, and then this. I know it's a lot to enter in. It's a very tough one for domain, especially because it's rid of a fraction in there, two different branches. That's really tough. But if you enter that into the first one, you will get the right answer. All right, so let's try another one. This one wants you to take function f, which is the square root of 5x minus 1, and it wants you to plug it into function g, which, like I said, I usually put the function in parentheses and then enter it in. So it would be squared and then times 6 minus 6. Okay. Now I'd simplify this, so I'd have this squared just gives you 5x minus 1 because the square undoes the square root. Then I have 30x minus 6, which would be minus 12. So 30x minus 12 is the function. And the domain of that then, you'd think was all real numbers because this is just a line, right? So you'd think, okay, I can stick in whatever I want. But I have to look at the original function that I've used, which is function f. Function f has a restricted domain. So those values stay restricted. They don't ever make it to function g, basically. Right? If the original function you're using has restrictions, those restrictions never make it to function g, therefore they're out of the composition as well. So let's look at the restrictions on function f. We have 5x minus 1 has to be greater than or equal to 0, which I can add 1 to both sides, so 5x has to be bigger than or equal to 1, divided by 5. That means that x has to be greater than or equal to 1/5. So my domain would be from 1/5 bracket all the way up to positive infinity, which means the same thing as this. That goes right here. All right, so far so good. Next one wants me to take function f and plug it back into itself. So I always take function f, 5x minus 1, put it in parentheses, and then stick it back in right here. So it'd be multiplied by 5, then we subtract 1, and then we take the square root of the whole thing. You could probably just enter that right in. I don't know that it simplifies that much. I mean, I guess 5 square root 5. This is over the whole thing. Square root 5x minus 1. Yeah, it doesn't simplify at all, actually. So that's what we're going to enter in, which is a little tough to enter in. But the domain, then, we have to look at the restrictions on the original function f, which we know that was all numbers that are bigger than or equal to 1/5. So we still have that restriction. Let's also look and see if there's any restrictions here. So let's take 5 times square root 5x minus 1. Minus 1 and set that bigger than or equal to 0. So if I add 1 to both sides and divide by 5, I get this. Now square both sides. You get 5x minus 1. It's greater than or equal to 1 over 25. Now add 1 to both sides, which I'll do as 25 over 25. That's 26 over 25. And then divide by 5. So instead of dividing by 5, I'm going to multiply by 1 over 5. And that gives me 26 over 125. So x has to be greater than or equal to that. And we actually have to take this one. So we're going to write that as 26 over 125 to infinity. The reason why is because if you look at a number line, we want all the numbers. We just found out that this is the more restricted domain, essentially, because this is 0.208. So here's 0.2, and here's 0.208. And what we want is all the numbers that are equal to 0.20 and to the right, all the numbers that are bigger than that. And this is 1/5 right here. So 0.2 is 1/5. This is 26 over 125. So 0.208 is basically more restricted because these values we just found out don't work. These values in right here, right in between 0.2 and 0.208, because they don't work into this function. When you plug them into this function, you get a negative number. So you have to take basically your most restricted domain, and that's the most restricted right there. We have to throw out those values. And it's a really tough problem. All right, the last one, g of x. So we're going to take g of x, 6x squared minus 6, and we're going to plug it into itself. So if we do that, we'll have that squared times 6 minus 6. This can go in right here. Now there's no restrictions on g of x, and so there's no restrictions on this one either. So the domain is going to be negative infinity to positive infinity. All right, the next one wants us to evaluate g of 1 and plug that into f. So g of 1 would be 1 to the 10th, which is just 1. And then we're going to take that and we're going to plug it in here. So since this is just 1, I'm going to plug it in here. It's 3e to the first power. So it's just 3 times the natural number e in your calculator, which you can just enter in as 3e. Okay, the next one, part B, g of f of 1. When I plug in 1 for f, I get 3e to the first power, and I need to plug that into g. So I'm going to have to raise that to the 10th power. You can enter it in like this probably, or you can do it separately, so 3 to the 10th times e to the 10th. Would also be another way to enter it in. All right, next one we just want to take g of x and plug it into f of x. So g of x is x to the 10th, so put that in parentheses and then plug it right in for f of x, which would be, go in the exponent spot right there. So that's what you're entering in right here, 3e caret parenthesis x caret 10. All right, so then g of f of x says take f of x 3e to the x, and we're going to put that in parentheses and plug it into g. So that'd be raised to the 10th power. Goes right here, 3e caret x, parentheses caret 10. And then this just says take the functions and multiply them together, but use t in the domain instead of x. So it would be 3e to the t times t to the 10th. And I don't know that we can really simplify that, so let's just enter that in right here. All right, this says this is not composition, this is multiplication. So it says take, I want to know what f times g of x is. So f times g, we're going to have to FOIL it unfortunately. F times g, this is not composition, equals x minus 2 times 2x squared minus x plus 3. So we are going to have to FOIL, it'd be 2x cubed minus x squared plus 3x. And then distribute the negative 2. So it would be minus 4x cubed plus 2x plus negative 6. And we can try to simplify this a little bit by adding like terms together. We got x cubed and x cubed, so that'd be negative 2x cubed. Take care of those. Then we have negative x squared, takes care of that. Then we have 3x and 2x, so that's 5x minus 6. So this is my function f times g. Just write it f times g like this so we don't confuse it with composition. Now, they also then, the next question wants to know what is the value of 2, so we might as well just stick 2 into this now. So 2 cubed would be 8 minus 2 squared is 4, plus 2 times 5 is 10, minus 6. So this is f times g of 2, which gives us negative 16 minus 4 plus 10 minus 6. So that'd be negative 20 plus 10 is negative 10, so negative 16 is what we'd enter in for this value. And the last thing wants f times g of negative 3. So we go back up and do now negative 3. So negative 3 cubed is a negative 27. negative 3 squared is a positive 9, and then negative 3 times 5 is a negative 15. And so that can simplify to 54 minus 9 minus 15 minus 6. So that'd be 45. Minus 15 would be 30. Minus 6 would be 24. All right, next question then wants the domain of f plus g. So if we add these functions together, f plus g of x gives us this new function, which unfortunately these aren't like terms, so I can't really simplify this at all. So I'm going to have to leave it just like that. All right, so the domain of this then is, well, let's look at this. We know that this has to be positive. 8 plus x has to be greater than or equal to 0. So let's subtract 8 and we find out that x has to be greater than or equal to negative 8. This one, x minus, or 8 minus x, also has to be positive. So let's subtract 8. And then let's multiply both sides by a negative sign, which switches the inequality. So we find out that x also has to be less than or equal to positive 8. So on a number line, that's negative 8 down here and positive 8 up here. We find out that x has to be less than or equal to that, and it has to be greater than or equal to negative 8. So we're looking at all the values in between here. So let's enter in negative 8 to 8, and we can do the brackets. All right, so the next one, f minus g. This was negative 8 to 8, brackets. Next one would be square root of x plus, or 8 plus x minus square root of 8 minus x. And we have the same thing here. If you know, both of these need to be positive, so if we do that, we get the same domain. So now f times g, so we have square root of 8 plus x, and then times the square root of 8 minus x. Now we can combine the square root of the whole thing, so we can make it 8 plus x times x minus, or 8 minus x. And we have to FOIL this now. So to FOIL it, we get 64. That's going to be minus 8x and plus 8x. Those cancel, so you get minus x squared, square rooted. Now this is the difference of two squares, so we know that it is that pattern. So they just want the domain of this though. So we want to take 64 minus x squared and set it greater than or equal to 0. So subtract negative 64 from both sides. And then multiply through by a negative 1, which changes the sense of the inequality. And then we'll square root. So we got, when we square root, this is the tricky part, we get x is less than or equal to 8, or x is greater than or equal to negative 8. So if we look at a number line, negative 8 is down here, positive 8 is up here. And we'll actually use the word and here and make a compound inequality, negative 8 to 8. Once again, we can include those values. So it's the same, it ends up being the same domain. Okay, but for the last one then, the last one is different. We're going to have f over g, so we have square root of 8 plus x over the square root of 8 minus x. Now, we still can't have negatives underneath square root, so we still have that same restricted negative 8 to 8 domain at this point. But we also have one more thing. We can't have a 0 in the bottom now. So we can't have x cannot be equal to 8, because that would give us a 0 in the denominator, which is undefined. So I have to change this closed bracket that typically would include 8. I have to make that not include 8 now. So that should work. All right, I hope this helps.